Hello everyone. Welcome to the class of quantitative methods of management. So we have discussed about arithmetic mean, median, quartiles in the last few classes. Now guys, in the present class we'll discuss about mode. Imagine that you are a marketing manager analyzing sales data for different product sizes in a popular clothing line. You notice that some sizes are sold more frequently than others, and you want to identify the size that sells the most, as it represents the most typical customer preference. So guys, question comes, how would you calculate this value by using mode, and why knowing it is very important in your inventory planning and working on maximization of your sales. At the end of this topic, you will be able to explain the calculation of mode when we have ungrouped data, explain the calculation of mode when we have group data, explain the calculation of mode when we want to work on grouping and analysis table, and then list down the merits and demerits of mode.
So talking about mode, basically the mode refers to the value in the distribution which occur most frequently. Okay, it is an actual value which has the highest concentration of items in and around it. According to Croxton and Corden, the mode of a distribution is the value at the point around which the items tends to be most heavily concentrated. Okay, it may be regarded the most typical of a series of values. Okay, so when we talk about the calculation of mode, imagine if the ungrouped data is given to you, as you can see on your screen, that we need to calculate the mode when we have terms like 2, 7, 10, 15, 10, 17, 8, 10 and 2, and for these series of data I want to know the value of mode. So for this you just need to see the value which repeated the maximum. Okay, so mode basically represent the data which repeated the maximum number of times. Since here that 10 repeated 3 times, so the mode is 10. Now when the continuous distribution data is given to you, then the formula of mode would be like this, as you can see on the screen. Okay, so here L is the lower limit of the class interval. Okay, while delta 1 is basically the difference between F1 minus F0. Delta 2 is basically the difference between F1 minus F2, where F1 is the frequency of the model class, F0 is the frequency of the class preceding the model class, and F2 is the frequency of class succeeding the model class. Okay, so here, by doing this calculation, if we get to F1 minus F0 or minus F2, if that comes to 0, then we calculate mode by the another formula, which you can see on your screen, where we'll use the logic of modulus, because whenever we apply the modulus function, then the output is always a positive. And so please remember, in this scenario, you apply the mode by using this formula as visualized in your screen. C is the class width of the class interval. Okay. So here you need to remember that if the mode lies in the first class interval, then the F naught would be taken as 0. Okay. The computation of mode pose no problem in distributions with open-ended classes unless the model value lies in the open-ended class. Then there would be a problem while calculating the mode. Okay, now if we have a continuous distribution, like as the formula, we have discussed about the formula in the previous slide. So here, imagine this is the problem, what you can see, that following class intervals are given to us: 0 to 50, 50 to 100, 100 to 150, 150 to 200, 200 to 250, 250 to 300, then 300 to 350, 350 to 400, and 400 and above. And we got the frequencies here, like 5 is the frequency between 0 to 50, 14 is the frequency between 50 to 100, and 40 is the frequency between 100 to 150, 91 is the frequency between 150 to 200, and 150 is the frequency between 200 to 250, 87 is the frequency between 250 to 300, and 60 is the frequency between 300 to 350, and 38 is the frequency between 350 to 400, and 15 is the frequency between 400 and above. And imagine if this data is given to us and we have to calculate the mode. So you just need to see that out of the frequencies, what is given, like 5, 14, 40, 91, 150, 87, 60, 38, and 15. You have to see the highest frequency. The highest frequency is 150. And you have to see the corresponding class interval for it. and the corresponding class interval for it is 200 to 250, which is the model class. Okay, so here your L is 200, your F1 is the you can say that the frequency of that class interval, like the highest frequency, which is 150. You can see out of these frequencies, the highest one is 150. So F1 is 150, and the lower limit of that is 200 is the L. And when you see this 150, the one frequency before that is called F naught, which is 91. Okay, and then one frequency after that is 87, which is F2, and the C is the class width, means the difference between upper limit and lower limit. What you can see here is 50. Okay, and then if you apply the formula of mode is L plus F1 plus F2 divide by, sorry, F1 minus F2, not F1 plus F2. So L plus F1 minus F2 divide by 2 F1 minus F naught minus F2 into C. So here, if you apply the formula, so if you just calculate this, we'll get the value of mode as 224.18. Apply mode mass appropriately. So if we are working on the calculation of mode when there's an irregularity in the calculations, for that kind of scenarios, we do a different case. Okay, like imagine for a frequency class distribution corresponding to the maximum frequency. But imagine that when you are working on these scenarios, you found that the maximum frequency is repeated in bimodal or multimodal kind of scenario, or if the maximum frequency occur in the beginning or the end of the distribution, or if there's a irregularities in the distribution, the model class is determined then by the method of grouping. Okay, so here, what is the grouping and analysis calculation? In this way, what we basically do, okay, we first write down the given frequencies, and then we actually make six columns. In the first column, we simply write down the given frequencies. In column two, we combine frequencies, two frequencies together. We'll make a pair of the frequencies and combine them. And then in column three, what we do from the data column one data, we ignore the first frequency and then we'll make the pair. Okay. When we'll do numerical, you'll understand better. In column four, what we do, instead of combining or adding pairs of frequencies, here we'll add three frequencies. Okay, three frequencies as one. Okay, and then in column five, we leave the first frequency and then we'll just add up the three frequencies together. And in column six, we leave the first and second column and then we'll combine the remaining frequencies three by three. Okay, then you'll get an idea about how will you work here with the this numerical. With what you can see your screen, that here you have this class interval. Okay, like you can see class intervals are there 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40. And then number of students are given to you 9, 12, 15, 16, 17, 15, 10, 13. Okay, so what we need to do, we need to construct the grouping table, and this is done to solve the problem as there is a large concentration of values 15 to 17, around 10 to 15, 15 to 20, 20 to 25. Okay, so the same logic is used here as what we can see there, that probably working on the simple formula will not make much sense. So here grouping and analysis table will make more sense. Okay, so for grouping table, when we'll work on, we'll make six columns. In fact, first column will simply write down the frequencies as what is given. Then in column two, what we'll do, we'll add up, like we'll make a pair of the frequencies. Like you can see the first two frequencies are 9 and 20, 9 and 12. So 9 and 12, if you add up, we'll get 21. So write 21. Then 15 plus 16, add up, we'll get 31. Then 17 plus 15, add up, you'll get 32. Then 10 plus 13, add up, you'll get 23. Then in column 3, what you'll do, you'll ignore the first frequency, which is 9. And then you make a pair 12 plus 15, 27. 16 plus 17, 33. 15 plus 10, 25. And one frequency left, 13, ignore it. Then in column 4, what you'll do, you make a triplets. Okay, 9, 12, 15, add up, you'll get 36. Okay, then 16, 17, 15, add up, you'll get 48. Okay, after that, you left with 10 and 13. Ignore them. In column 5, ignore the first frequency. Then add 12, 15, 16. You'll get 43. Then 17, 15, 10. You'll get 42. Okay, then you left with 13, ignore it. Column 6, you ignore the first two frequencies, 9 and 12. Then add 15, 16, 17, you'll get 48. Then 15, 10, 13, you'll get 38. Okay, now once you get this grouping table, now what you do from each group, see the frequency which is highest, and then mark them under this. Okay, whichever frequency is highest, just mark them. Like here, when you notice 0 to 5, and in which in 0 to 5, here you just write down the class interval. Left side and right side, you write down the column. So in column one, the highest value. What is the highest value in column one? So the column one, the highest value in the column 1. The highest value in column 1 is, which value is highest? Is 17, right? In column 1, the highest value is 17. Okay, in column 1, the highest value is 17. Okay, and that 17 belongs to which class interval? 20 to 25. And then in column 2, the highest is 32. And 32 belongs to which class intervals? 20 to 25 and 25 to 30. Because 32 you got by the sum of 17 and 15. So in column 2, the highest figure is 32, which is because of 20 to 25, 25 to 30. In column 3, the highest value is 33. And in that 33, because of 16 plus 17. And that is because of 50 to 20, 20 to 25. Then in column 4, the highest value is 48. And that 48, how you get 48? Because of the sum of 16, 17, 15. So because of which class interval? 15 to 20, 20 to 25, 25 to 30. Just mark them. In column 5, similarly in column 5, the highest class, the highest value is 43 because of 5 to 10, 15 to 10 to 15, 15 to 20. Column 6, the highest value is 48 because of which grouping, because of which the summation 15, 16, 17, which is 10 to 15, 15 to 20, 20 to 25. And like this, you simply mark them. Okay, every column, see which is the highest value, and that highest value you got because of the which class interval. Just write them. Okay, just mark them. Then when you mark them, when you get the highest value you are getting for the class interval 20 to 25. So the required class interval is 20 to 25. The L would be 20, and the corresponding frequency of 20 to 25 would be your F1. One frequency before that would be F naught. One frequency after that would be F2. Last width here would be 5. So here I already explained you. Yeah, you just put them in the formula. Okay, what is your L? What is your F1 minus F2? What is F naught? F1 minus F naught? Just calculate them. Okay, and then calculate the mode by using the mode mass. Okay, so when you do this, we'll get the mode as 21.67. Okay, the graphic representation of mode. Whenever we work on the graphical representation of mode, then we use histogram for the class interval data with frequency. What is given, we'll draw the histogram, and then we'll focus on that frequency or that group of the histogram which has the highest frequency. Okay, and then we draw a line, okay, which connect diagonally from one end of the highest value to the other end of the histogram, the rectangles of the histogram, and the point where they get intersect will give us the mode. So here we when we get this representation, so we just focus on the histogram, and we'll while observing that histogram, we'll select the class interval which has the highest frequency. Or if you see the rectangles, if you see the histogram, choose that peak of the histogram, okay, which is highest. Like consider all the all the all the representation of histograms as a building. So choose that building which is of the highest. Okay, and that highest frequency class interval would be your required class interval. Okay, so you just need to draw the line which connects from the one vertices of that figure, okay, to the other end of the representation. And when you draw the two lines, the point where they get intersected on the x-axis, that is the mode. Okay, talking about the merit of mode, it is easy to calculate and can be located by inspection. Mode is not at all affected by the extreme value. It is calculated even for the open-ended classes, and it is usually an actual value of an important part of series. And in some circumstances, it is best representative of data. demerits of mode, it is not based on all observation. That is a problem, because like mean, it is not based on all the observation. So if you change the extremes and all, the mode is not much affected, because of which it is not capable of further mathematical treatments. Okay, mode is ill defined, as it is not possible to find mode in many cases. Okay, it is largely affected by the sampling fluctuations, and it is unsuitable in cases where the relative importance of items has to be considered.
So in this topic, you have learnt about first, we have learnt about mode. Mode is most frequently appearing value in the data set, making it most typical or representative value. When we talk about mode, mode is easy to calculate, not affected by extreme values. It is applicable for open-ended classes and often represent the most important part of the data set. It is not based on all observation. When we talk about mode, it is not based on all observation. It cannot be used for further mathematical treatment, and it can be ill defined or affected by sampling fluctuation in certain cases. So I hope you have understood the concept of mode. Here in this class, we worked on the basic understanding of mode. We worked on the numericals based on mode, either it is raw data or group data. It is not based on all observation. It cannot be used for further mathematical treatment, and it can be ill defined or affected by sampling fluctuation in certain cases. So it's time to wind up this session. Thank you everyone. Happy learning.